So I've completed the rest of the tail lamp perimeter and turned down a few other parts just to let us diagnose what the relationship is. So we have the quarter panel, we have the blackout, the lens with draft, radius, and offset. That makes its way around this corner. And we have a similar fit and finish right here with lens die draft, quarter die draft, and a part gap. Now, we could discuss and deliberate this being 2.5 millimeters. Maybe it's 1, so it would only be this much. But that's separate from being able to just construct the geometry. That's an engineering negotiation and a design negotiation versus trying to create the geometry. So we can create the geometry at the values that are given, and that's not necessarily the Class A surface person's area to control. This would be engineering and design to negotiate that. Now you can help facilitate that by creating the geometry and showing that that looks like an excessive part gap, but it's not really our job to do that, okay? At least in my experience. So I've created that geometry, and an additional thing that I did is I added a evaluate curve to curve. I added a normal flange between these two areas that is 2.5 millimeters. So what that's going to do is allow us to create some other geometry. Okay? So I'm just going to switch now, and I'll delete those locators. Let's just go into orthographic viewing mode. I've got a variant set up here just to go to the lens and the blackout. So if we wanted to investigate those parts a little bit further, we could. But what I'd like to talk about is just to go into this lamp folder and click the criteria layer and talk about what our first step is for our next part. So basically what we've done here is we've developed this piece and this piece of geometry and this piece of geometry. So in this scenario, which next we want to develop this break piece of geometry, okay? We need 2.5 millimeter offset and 2.5 millimeter offset. So we need to construct this surface, okay? So I'm going to turn that off for now. And if I turn on a break construction layer, I've already selected and offset this data, so 5 millimeters. And if we just investigate this a little bit, I want to show you just a couple options inside the offset tool. And by default, we're offsetting in normal mode. So that's just the approximation mode for how the tool calculates the offset surfaces. And you can see we get some disturbances and some strange CV placement, I guess I would call it. If we switch the normal from normal mode to normal U and V offset, we get a bit more structured offset in our surfaces. So I'm going to use that mode. And from this point, what we would need to do is determine if we have a valid offset for use in our break part. So if we pick this data and we do an evaluate check tangency, you can see here that we've got quite a few errors. So if we just do a quick look at the errors, we've got an error here, 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 here. This is showing something, and sometimes this is so far that it can't even check the error. So we can see that there's a gap there, but it's not even close enough to check. Okay, so we basically have gaps almost everywhere in this offset, and this can happen quite often. So when this happens, what I'll do is this: delete my construction history. I'm going to untrim and use the all option. Just get rid of all trimming. Okay. What I like to do right after that is go right back into the untrim tool and set it to last and go. Now, when I do an untrim, it won't untrim all, because oftentimes I just want to go back one step. Now what I'm going to do is delete some of these curves on surface that are extraneous, because I'd like to get down to just what I need for my work. Okay, so we'll get rid of some of these pieces. I don't think we're going to need that or that. Should get this. We don't need that little piece in there. We don't want any of these little pieces. Okay, just because they're not necessary. All right, and I'll get rid of these things. Okay, I think we can box this off with that. All right, now a couple little loose ends over here. I've got a couple of areas that I know won't trim, so I'll just do a quick extend with the original of your friend and this guy here to make him go up there. Okay, now we've got kind of a smaller and larger slabs here, and I'm just going to start with the larger ones, I guess. And I'll go to align, and I'm going to align this upper one to this lower one, and I'm going to do an edge alignment there because I want their two raw edges. And you can see your numbers right here. You just need to look at the maxes and be sure they're below 0.0001, 0.1, and 0.1. Those are the values that we're working to. Okay, so we're within the tolerance. If you'd like to see that graphically, you can turn on the specify check, switch it to curvature, and now we can see that by the locator, we're aligning for position, G0, but we're achieving G2. Okay. Next, I'm going to align this edge to this surface. It kind of freaks out a little bit because I'm doing edge alignment and I need to be doing project. Okay, so that didn't work. I'll revert that. Align from here to here. Okay, it has a try at it. And what it's finding right now is that it's having trouble probably aligning at this corner. And that's because this corner sits outside of this surface. If I hit shrink to fit, it slides that back, and now I get a nice fit. And I'm checking for positional only, denoted by the P. But if we look here, 0.1 and 0.1, we're okay. I'm just going to ask for G2. Okay, pick nothing. Do this other edge, same thing. Okay, that looks pretty good. Now I know right here I've done a little bit of movement in this edge. So my first, I guess, option here is going to be to align this to this friend over here, and I'm going to do it via edge alignment. That way it lines it right up. Okay? I'm not going to so much concern myself with the tangent and curvature right now because I need to drive those from this side and this side. Okay, and to achieve that, I'll align this edge. I'm going to use projection onto this surface. Okay, I'm going to ask for G2. And you can see here we've got a little bit off. Maybe I'll go for G1, I'm sorry, to start. You can see here I'm above 0.1, so I'll go to G2. And I'll do the same on this edge. I'll ask for alignment between there and there. Okay, and we're well within. Pick those surfaces now, delete the construction history, turn on their control vertices, and I just want to snap this one control vertice onto there. Okay, then I'm going to ask for what is my continuity. Ask if I get curvature, bring that up a little bit, bring this up a little bit, and I'm just going to do a couple of CV edits here. I'm going to align to projected here, and then normal UV, grab one, and just bump that control vertex. Okay. Now next, object edit, align. Let's align this surface using projection onto this surface. Okay. And I'm not going to use shrink to fit. And let's just bring this down. And right now it doesn't want to align. And why might it not want to align? Well, I'm going to use the shrink to fit option and see if that will pull it back. And it's not. So most likely it can't determine, okay, right now, where it's supposed to align to. And typically that means that on the end boundaries, you're missing right here, or you're missing over here in a direction that it's not able to achieve, okay? It's not able to calculate that. So I'm just going to revert that. Pick this edge again. Select this surface. And see if we can get an alignment by adjusting this positional influence. Sometimes that will make it happen, and it doesn't, so I'll revert that. I'm going to grab this surface, turn its control vertices on, and I'm going to snap this one control vertice. Pick this control vertice, and I'm going to snap that control vertice to that location. Okay? Now, shrink to fit should have worked, but it's not in this case. Object edit align. Let's see if this, revert. Let's see if this makes this happen. And we're going to revert that and go from here to this surface. And now it aligns. And you can see when it aligns, it doesn't disturb the alignment of either end. Okay? So now let's align this edge to this surface. Okay, and I'm just going to do that for G0. Look at these numbers. I can adjust this to curvature just to see if that's okay, and it is. Now I'm going to align this surface to this friend. Okay, we look over here, it's fine. I'm going to align this surface now, edge alignment, to here, and check it for curvature, and that's okay. Okay. Now that we've done that, we've got a little situation over here. And what we have is a larger slab where another slab comes halfway across and meets and then goes around. So in this case, I'm going to align first this surface's edge using projection, no shrink to fit. This can be at 0 to this surface, okay? You can see here as these crowd point 1, I know I've got a problem. So I'm just going to align for curvature, okay? And now, here's an important step. Since I know I want these to touch right at the edge of this surface, I'm going to turn their control vertices on, and I'm going to come in here and grab those two endpoint control vertices and just zoom in, and I'm going to snap those right onto this edge, okay? And then zoom back. Now I'll do an object edit alignment between this surface using G2 and projection onto here, this surface onto here, and actually in that case right there, I'm going to query edit that, and I'm just going to turn on my explicit control and just maybe bring this down so it allows me to go down to 7. I'll align this to here, maybe try going down. Okay, it's got that. All right. So we've got all those within alignment. I'm just going to do a couple of checks here. We got curvature, curvature, and curvature. Okay. So I don't always do all this stuff using the align function, because a lot of things can happen using the align function that I don't see. So once I've got some basic alignment, I'm just going to use some control vertices snapping and align these CVs together. Okay, so there's a little curvature issue. Now we'll use a normal U and V, get this to align. We've got kind of need a little bit of mouse sensitivity to get that to align. Try to get this to align. And then here we do the same thing. Grabs a couple control vertices, grab this one to here, this one to there. Just gonna get these aligned. I could have done this with a edge alignment and it may have worked. So let's just try that. Object edit, align. Maybe I'll align this surface to here and we're good. Okay, you can try that. Sometimes it will work, sometimes it won't. Okay, now that we have all that trimmed or all that aligned, I'm just going to pick this. Oops, I've got one edge right here with a P. So I'll hit curvature, grab this, delete it, check it. Okay, everything appears to be curvature. Delete locators, pick all this data. We've got intermixed history. I'm going to delete that history. Okay, and then I'm going to do some trimming. So let me just trim this to here, trim this to here, a little bit of trimming in this area, turn my things off, trim this down in here, and now this is an interesting area because I have a long COS and a short COS, and another long COS that are almost continuous for a long range right here. What I'm going to do in that case is, now that I've trimmed this piece right here off, I'm going to project that. So now I don't have two confusing pieces of geometry, and let's trim that off. Now this is my offset surface, and I can do an evaluate for tangency and see that I've got a nice clean surface that can be used for my brake now. Okay, so now if we go to our blackout, all right, our next step here under the criteria was to add a X-base draft at 3 degrees, okay, off this point. Now we're not going to do the 2.5 offset yet, but I can see that from right this point, I need 3 degrees, right, from X. So I'm going to go do that, okay? So I'll turn off my brake construct. Actually, let's leave brake construct on to make it our construction layer. Okay, so I'll do surface, multi-surface draft, and I'll just have chain select on temporarily here. And I'm going to grab this piece, and we need X direction, okay? And I'm actually going to pick this guy so it goes backwards. And we can see what we've got here. And this looks pretty good. We've got decent amount of surfaces, and it looks pretty good in this corner. One thing that we've discussed already now, though, is that I don't have radial. But prior to checking what radial will do, I just want to see how this is starting to stack up in this corner. Because I know back in the background I have a blocker back here. So if we turn on some shading to see just some maybe critical geometry that we have constructed here, what I have is our blackout surface. It's offset. Okay, this is up where my turn signal is going to be, or my brake is going to be. And then if I use this edge, right, and I make my draft, I'd never get down to my blocker surface. Okay, I would like this piece to be somewhere over here. I know I can offset it, but it's way outside. I'm not going to meet my criteria at all. All right. Well, my criteria is one thing. I'm going to meet the criteria, but the current basis isn't going to make the design feasible. So I'll take a little bit of liberty here so that I have something done in the morning, I guess, when people come and want to see this. And I'm going to go back to my construction layer, and you know what? I'm going to say, if you're using this die vector right here for everything else, I'm going to try to use that die vector. And then I'm going to look at that and see how that comes out relative to my blocker surface. Okay, and I can see here that, well, I'm almost meeting inside my blocker surface, the green. Okay, and as soon as I offset this for my for the gap, I should be okay. But now that we've kind of seen that, and I'm going to turn off my blocker and the blackout. Now that I've kind of seen that, and turn my shading off, now we need to switch to radial. So if we switch to radial, we get a little different result around here. But mostly what I wanted to look at is how now in this corner, the fillet is trying to be built radially. And this is a situation where the draft surfaces need to be built radially, but the fillet surface should be built to the theoretical. And here's the difference, okay? So I'm going to undo this, turn back on my blackout, which is where I got my stuff from, and just pick a couple of pieces here just to stop it from chaining and template those, okay? So if I go right back into my draft, same settings, this guy, picking this, okay, and I say go. All right, we see this, and then if I hit unradial, we see this. So I want a combination of these two things, okay? I want radial for all my slabs, all right? Then I'm gonna grab all these fillets in the corner, and I'm gonna construct this fillet in this corner, based on this or based on that vector. And I'm going to do oops, undo all, turn off chaining. And this corner based on this, okay. And I'm not going to do it radial. All right. And then I'm going to take my my flange surface, extend it till it's just past, then extend it a little past. Take this, extend it skew till it's a little past, and then extend the whole thing. All right. Now I can extend this surface a little bit. Okay, yes. I can take this surface now and extend its edge just a little bit. Object, edit, align, G2, projection, edge and edge, edge and edge, okay. Edit, trim, and it doesn't want my, so failed to extend curve on surface. A lot of times, not a lot of times, sometimes I find that I'm unable to take a curve on surface and extend it, and you get this message, maximum extend distance exceeded. Well, this is a current bug in the product. So when you run into that, delete the curve on surface, reproject the curve on surface, and then you'll be allowed to extend that. We're currently working on this, and I'm sure a fix will be out soon. Okay? So now this is actually our surface that needs to be intersected with our brake surface. All right? So just as we did before, we need to repair a little bit of angles, offset that surface, and once we do that offsetting, okay, once we do that offsetting of this surface, we'll have this surface, okay, and those are just offsets of one another. All right, and when you do some trimming and intersecting, and I'll just turn off my brake construction, we'll have this set of data. So we'll have this upper brake where the top is open 3, the bottom is open 3. Okay, move on from that with the same offsets. You'll get your turn marker. I've got the blocker surface trimmed out. And then behind that, there's just a simple larger offset to cap the whole thing off. Okay, so pretty nice layout right now of surfaces meeting all the criteria. Okay. Now, one problem that I see, and I'm going to turn on all of the parts here, and let's just add a couple of these back in and turn off some of our surface boundaries just so we can see this a little bit better. Well, one thing that we have in Alias is a couple of little issues with the OpenGL graphics and dealing with transparencies where we get some flickering of the different colors when we go through multiple transparent objects. Okay, but a bigger thing that I see, if I turn off perspective viewing and we go to orthographic viewing and I just look at this straight and aside view, okay, I'm going to turn on anti-aliasing, and this edge has an S in it. So to see that more vibrantly, if we stretch this up and I make it flat on the screen, okay, so we've stretched it up now, and now I want to twist it on the screen, and I'm going to make this edge flat. So we have a nice edge of part down here that's nice and flat. Edge of lamp, nice and flat. All of a sudden, our blackout is not quite flat. That gets more accentuated in the brake marker and even more accentuated in the turn marker. So what's going to need to happen here is that we're going to have to use the minimums that we meet, okay, and then construct some geometry that goes from our minimums that are maybe curve degree 1, maybe our minimum that's somewhere around here, crossing this point, okay? And then if I extend that, okay, to get a clean edge through there, and I'm just going to rotate this and move that out, straight out in the side view, to get a clean edge through there that's nice and straight, instead of it being a perfect offset, okay? And I'm just going to turn our surfaces up a little bit. We may need to be a little bit more than 10 millimeters of flat right here and here to keep 10 here, 10 here, and 10 there, but a nice clean edge. And keep doing that in every offset, okay? That's called drafting, okay? Right now we have all the proper engineering offsets, but as a design model, it's not gonna look that good, okay? You can't have these type of S's. So at this point, we would need to go back and begin to recreate and optimize this model to make these edges all nice and clean. Here on the top, I think we're decent and pretty good. We can turn up our transparencies if we want, just to see that. So we're pretty decent, but you can even still see in here some little undulations, okay? And that's just due to all of the stacks up of offsets and draft angles. Okay, so the next challenge is going to be to refine this model beyond a Class A surface model of boundary conditions that have been offset to perfect numbers. Now we need to make a design model that achieves all of this, okay, meets all the criteria and satisfies the design.